Hey everyone, so check this cool proof of concept that I threw together today. It's really cool in my opinion because it highlights IoT, LoRa, and connecting to the IOTA Tangle. So it's kind of a nice scalable proof of concept because if anybody knows LoRa based protocol, it's kilometers of range, very low power, low bandwidth, but I don't need a lot to send the information that the sensor has, or really most sensor applications are fairly low from a bandwidth packet size perspective. So it's a cool concept, and you can use your imagination on what you could use it for. So check it out. Here we got the sensor. It's basically a little weight sort of rocker switch based on its vertical or horizontal orientation. That part doesn't really matter. I just wanted a sensor that you could think about a practical application, but also gated the communication. I didn't want this pushing information to the tangle all the time. I wanted to be able to turn it off and on based on the status of the sensor. So then that connects to an ESP32 with a LoRa antenna. So it sends the information to a Dragino LoRaWAN Gateway. And that is cool because that's equivalent and actually can be used as a helium data only gateway. And if anybody knows anything about helium, you would know that that is the protocol that it natively speaks on the sensor side, which is LoRa. So this could be used in the helium architecture as well. Based on the sensor and the code that I've written here, it's essentially functionally identical. There's a little bit more you would need to do on the integration side of the helium gateway, but I've done that too, and it's reasonably easy. So I have the Dragino translating the information to MQTT. I have a secure Raspberry Pi translating that information and sending it as a broker to the IOTA Tangle. So let's go ahead and show you how it works and read some data and just have fun ultimately. So what I have here is I have the Arduino code. It's currently running. The sensor is currently has a value of 0, and that's just based on the fact that the sensor is not active. And here's the Arduino environment. It's C++, really, for anybody who doesn't know. So let's go ahead and look at the hardware here. So this is the microcontroller, really economical, basically tens of dollars. So really cheap, but very, powerful, low power as well. I've had this thing send information, using 15 milliamps of power, so it's pretty cool. I've got a little sensor there, as I said, is not really that important, but shows the concept. And the cool thing with this is it has analog inputs, so you could be measuring temperature, vibration, various things like that. There's the little antenna. There's my Raspberry Pi. And here's the LoRa gateway. So the cool thing with this is, of course, I'm not taking advantage of distance here, but you can go upwards of, I think I've seen it about 1.8 to 2 kilometer radius. So huge range. And if you create a mesh network, you can span quite a bit of distance. This microcontroller can actually be used as a gateway as well. So I could have a mesh network and use kind of a repeater concept with at least one of them with WAN access to connect to the internet. So really cool stuff. It should be noted that cable is for power only. So here we go. We're sending a 0 still. Let's go over to here. I've got a little Node-RED code here, and it's basically subscribing to that broker that I spoke about. There's a little function to package the data. Package it as a JSON string and then send it to IOTA to Tangle, and that is utilizing this thing called Streams MQTT Gateway. It's a pretty cool little bit of code here. So what I'll do is spin that up. When it starts and connects, it will give me a channel address. So there's the channel address. It is currently listening and ready to send the data when it receives it. So that little bit of that far left node is currently listening and subscribing to that topic. Nothing is active on there, and I'm currently writing a 0 to the, well, the sensor is currently outputting a 0. So there's a little bit of logic here, which is basically saying if equal to 1, go ahead and send that. So check this out. I'll flip this up. There's a little ball bearing that will make the circuit. There we go, sent data. Check that out, new message received. There's the confirmation. So what I can actually do now is go ahead and grab that channel address. Copy that. I'll open up Explorer. Let's paste in that new channel address. And there we go. And timestamped data sent from LoRa sensor, and I sent a little hello packet. So there you go. You know, a neat proof of concept. I could see this being scalable for many IoT applications. Anything using LoRa, helium, you could create your own gateway, as I said. You can use open source gateways. There's so many possibilities. The low power is one of the major benefits, I would say, of this sensor. You know, it's very powerful. So I hope you can sort of see the advantages and the simplicity of it. And I hope you like the video and like the technology. And I want to keep going on these cool proof of concepts and ultimately make this into a real product and solve customer and business problems. So let's keep talking about this technology and continue to develop and do some really cool stuff. So thank you for watching, and I hope you like it.